And today I'm going to talk about hydrogen BAJA SA India, which is open for UG and PG from the same college, undergraduate students from first year to fourth year of engineering, and postgraduate students in the first year and second year of their masters. There was a question, so I must tell you that mBAJA and hBAJA event would be concurrent at Netrex Pithampur near Indore. Since both of them would be using engine, we will be doing this event concurrently. And BPCL, Bharat Petroleum, has been kind enough to provide speed petrol for mBAJA and CNG for hBAJA event. Why do we call it hBAJA and not cBAJA? I will tell you as we move ahead. Our final aim is hydrogen BAJA, but we would start with CNG and then shift to HCNG and then finally hydrogen. As you know that our primary objective is to make you industry ready, and all this all-terrain vehicle needs to be hDesigned as per the BAJA rulebook. Mr. Mundra has explained you in detail how to design a BAJA vehicle, whether it is eBAJA, mBAJA, aBAJA, or hBAJA. The skeleton of the vehicle, the roll cage remains same, and the suspension and steering and brakes also remain the same. So as I told you earlier, everything is designed revolved around the roll cage, which makes the driver safe, and other safety aspects are a 5-point seat belt, 2 kill switch, 2 fire extinguisher, the entire kit which the driver has to wear, and so on. And also a detailed C analysis is done to ensure that the roll cage is 100% safe and the factor of safety is very good enough. The event, as many people have explained you, is divided in 3 parts: preliminary, virtual, and the physical event. And there is also an HR meet. Now I'll talk about hydrogen. Hydrogen is one of the lightest element in nature and it is renewable. Hydrogen is a clean fuel with the highest energy content in terms of mass. And hydrogen can be used for power generation and also as a fuel in automobile. Hydrogen has been used as a fuel in spacecrafts. It is possible to use hydrogen directly in IC engine as a fuel independently or mixed with diesel or CNG. Also, it can be used in fuel cell to directly produce electricity. So when we use it in IC engine, the hydrogen energy, the chemical energy of the hydrogen is converted into mechanical energy, which is given to the wheel. And if we use fuel cell, then the chemical energy is directly converted into electrical energy. So when hydrogen burns, what we get is water. But if the hydrogen burning temperatures are high, then NOx is a byproduct. And it is therefore not only an efficient energy carrier, but a clean and environment-bending fuel as well. Hydrogen can substitute fossil fuels like gasoline and diesel, and therefore reduce our dependence on imports of crude petroleum. So worldwide, whether it is Europe, whether it is USA, whether India, we don't want to be dependent on import of crude petroleum, and hence everyone is working to find out an alternate fuel, whether it is CNG, whether it is LPG, whether it is biodiesel, whether it is ethanol, methanol, electric mobility, and hydrogen. So recently, our Prime Minister has committed that India will become energy independent by 2047. That means we will stop buying crude petroleum by 2047, and we will achieve net zero. That means the carbon dioxide emissions will be zero by 2070. And for that, we recognize the critical role of green hydrogen. When I say green hydrogen, anything which is produced, the hydrogen which is produced in a sustainable way, like use of solar energy, wind energy, hydel energy, or nuclear energy. So India, with its vast renewable energy sources, also has the opportunity to produce green hydrogen for the world. So we can even export green hydrogen. We are very much blessed with good wind and good sunlight, and hence wind energy and solar energy can be used. So Ministry of New and Renewable Energy, MNRE, is the nodal agency to drive the hydrogen program in India. Yes, there was a committee formed in 2005, and then another committee was formed in 2013, and they came out with a lot of recommendations. But the final National Green Hydrogen Mission was launched just before 3 months in January 2023. And this green hydrogen mission aims to provide a comprehensive action plan for establishing a green hydrogen ecosystem and catalyzing a systematic response to the opportunity and challenges of this sunrise sector. So MNRE will be responsible for overall coordination and implementation of the mission. You can just Google National Green Hydrogen Mission and you will get this document. And the objective of this mission is to make India the global hub for production, usage, and export of green hydrogen and its derivative. So there are many mission components like demand creation, incentivizing, key enablers like resource, infrastructure and supply chain, R&D, regulation and standards, ease of doing business, and skill development and public awareness. So all these things are a part of the mission, and using this key enabler or supporting this key enabler. So it is similar to what we did for electric vehicle and we had FAME. Similar to that, there will be a lot of subsidies for hydrogen. Today, hydrogen is costing 500 rupees per kg, whereas CNG is less than 100 rupees per kg. So there is a huge cost. We are sure with mass production and sustainable production, the cost of the hydrogen will come down in the years to come. So the expected outcome is that we must be able to produce 5 million metric ton of hydrogen per annum with a renewable energy capacity addition of 125 gigawatts. For this government is ready to invest 8 lakhs crores, and this will give jobs to 6 lakhs people, and 50 million metric ton of carbon dioxide would be saved. So there is a duty of Ministry of Skill Development and Entrepreneurship and Ministry of Education to do hydrogen awareness and various skill development program. So ASDC, Automotive Skill Development Council, will do series of awareness program and skill development program in this area. There are already organizations like Banaras Hindu University, IIT Delhi, IIT Madras, who have been doing research on hydrogen engine technology, and OEMs like Mahindra, Tata Motors, Volvo, Toyota, Ashok Leyland have already started working on hydrogen. Reliance is also running 10 vehicles with hydrogen as a fuel, and Reliance is coming out with a big plan to produce green hydrogen and also carbon fiber production, which can be used for producing cylinders for storage of hydrogen. BIS also has come out with various standards related to the fuel and the cylinders. ARI has also done series of work, and they have fired an engine with HCNG, that means 70% CNG and 30% hydrogen. Indian Oil Corporation and Bharat Petroleum are taking active steps to establish distribution infrastructure of hydrogen and HCNG in India. So there is something called PESO, Petroleum and Explosive Safety Organization. They have been working from Nagpur, and earlier it was known as Department of Explosive, and it is under their purview to ensure safety by use of fuel, and they have amended gas cylinder rules for hydrogen and CNG storage, and type 3 composite cylinders are granted permission for the trial. So basically any cylinder are of 4 types, all steel called CNG1, fiberglass hoop wrap steel liner called CNG2, all carbon fiber wrap cylinder called CNG3, or fiberglass carbon full wrap cylinder called CNG4. So CNG1 and CNG2 can be used for CNG, and CNG3 and CNG4 can be used for hydrogen as a fuel. Hydrogen has a property to embrittle the metal, and hence we cannot use stainless steel when we have hydrogen as a fuel. But up to 18% hydrogen in CNG, one can continue using steel. That means when we want to shift and we want to do a transition from CNG to HCNG and HCNG to hydrogen, we can continue the same engine CNG with 18% hydrogen. And that's what we plan to do. So there are various properties of the fuel which we need to understand. Hydrogen independently, or hydrogen CNG with 5% of hydrogen, or CNG, pure CNG, that is methane, CH4, and gasoline. You would see in the third line, minimum engine for ignition is only 0.02 millijoule for hydrogen compared to 0.2 to 0.3 for HCNG, CNG, and gasoline. So hydrogen is very explosive. It can ignite very fast. and hence we need to be very, very careful. And let's look at octane number. Generally a gasoline octane number is around 90-94. CNG octane number is higher than 100, between 100 and 110. If you add hydrogen in CNG, it can be anything between 100 to 130, and a pure hydrogen octane number would be more than 130. So we can use higher compression ratio if we are using dedicated fuel. Similarly, calorific value also, as you move from gasoline to CNG, CNG to HCNG, and HCNG to hydrogen, it increases. So between hydrogen and gasoline, the calorific value increases 3 times. So a lot of experiments have been done to test CNG with 0 hydrogen, 10% hydrogen, 20% hydrogen, and 30% hydrogen blended in the fuel. And there has been very good success in terms of testing. If you use more than 30%, you need to use spark arrestor in the front and rear. So we need to be careful, and that's how we will create awareness as we move from CNG to HCNG and HCNG to hydrogen. So how do we do this transition from CNG to hydrogen? So CNG was introduced in Delhi first in April 2001, and all the vehicles, all the transport vehicles, the auto rickshaws, the taxis, and the buses were converted into CNG compulsory through the Supreme Court notification, and that reduced considerably the emission levels in Delhi. And then recently, HCNG was introduced with 18% hydrogen. It is at the experimental stage with the help of Indian Oil Corporation. And that is the next step to start using some portion of hydrogen, which will increase the octane number and it will increase the calorific value. So if you look at the technology, we started with conventional vehicle technology, and we kept on increasing the thermal efficiency, mechanical efficiency, and the volumetric efficiency of the engine. And then we did a lot of improvement in the conventional fuel, reduced the sulfur content, reduced lead. So lead was totally abolished so that we can use catalytic converter. Also phosphorus in the oil was reduced, and we started using synthetic oil. Then came alternate fuel, as I told you, like CNG, LPG, ethanol, methanol, biodiesel. And then we started electric vehicle technology through FAME, and hybrid are yet to come. But the future for tomorrow is hydrogen in the form of a fuel, or hydrogen as in the form of fuel cells. So with this background of hydrogen, HCNG, and CNG and its transition, I will not talk about hBAJA. So the challenge is that we must initially use CNG, then in subsequent years use HCNG with 18% hydrogen, and slowly ramp up the percentage of hydrogen to 100% as and when the country is ready with mass production of hydrogen. Vehicle can be any type: 2-wheel drive, 4-wheel drive, all-wheel drive, and hydrogen engine necessarily need to be an IC engine. So that would be a transition from mBAJA to hBAJA. And similarly, autonomous vehicle BAJA would be transition from electric BAJA. So electric BAJA will get transition to autonomous BAJA, and mechanical BAJA will get transition to hydrogen BAJA. Yes, the engines are different. I will talk about the engine. And as I told you, as we will ramp up on the hydrogen percent as we move forward. So we will require a powertrain, we'll require the engine, we'll require the transmission, and we will have to understand whether we want to use a normal gearbox, a CVT, what will be the ratio, what will be the tire size, depending on the maximum speed. As on today, the maximum speed of the BAJA buggy is 60 km/h. And we also need to have acceleration to win the race, and also gradability to hill climb the event. So finally, I would like to declare that for hBAJA, Greaves has agreed to give us engine at a very low cost, nominal cost. It is a single cylinder, 4-stroke, naturally aspirated, water cooled. That means we'll require a radiator, electronically controlled CNG injection bi-fuel engine. So it will have a petrol tank, it will have a CNG tank. And when we are running in the competition, we will be using CNG. But when we are not running in the competition, we are allowed to use gasoline. So gasoline and CNG both will be available at the site. You will not be using your fuel. BPCL will be supplying equal quality of fuel to all of you. So this is a 396 cc engine that is around 400 cc, similar to Briggs and Stratton with a bore of 86 and 68. In a Briggs and Stratton engine, the compression ratio is 8. Here the compression ratio is 9.5. And it's a 10 horsepower engine, same as Briggs and Stratton. The torque is slightly higher, 22.5 Newton meter. The total dry weight of the engine is 47 kg, so approximately 50 kg with lubricating oil. And 15W50 oil is used, and the cooling system will have 40% water, 40% ethanol glycol and 60% water. And the fuel tank capacity, that means the petrol canning capacity is 3.8 liter. Okay. Just a couple of slides left. So finally, for BAJA SA India, just 1 minute, I missed one slide. Okay. Finally, for BAJA SA India, 2024, we will be using 100% CNG. For BAJA SA India 2025, we will be using CNG with 18% hydrogen, that is HCNG. And for BAJA SA India 2026, we will increase the hydrogen content in HCNG as and when the country is ready to supply similar fuel. So I would like to say that there are a lot of advantages of using CNG, and its octane number is higher. It's a good lean combustion, abundant availability in India, and there is no sulfur content. There is no lead. It emits less carbon dioxide, less carbon monoxide and hydrocarbon, maybe equivalent or slightly higher NOx, and it can be used with gasoline or diesel. Some of the issues which we need to tackle is it has a lower volumetric efficiency, leading to a power loss of around 10 to 20%. If you are using biofuel, that means sometimes petrol and sometimes CNG, we have to manage with 9.5 compression ratio. If it is dedicated CNG, we can increase the compression ratio to 10 to compensate for the same power. But if we increase the compression ratio and still use gasoline, then there would be detonation. Hence, we need to use 9.5. We cannot increase the compression ratio, and you can use biofuel. CNG has to be stored in the vehicle somewhere above the engine. Engine would be in the rear, and the cylinder would be in the rear, and also the petrol tank also would be in the rear. We need a lot of infrastructure for supply of CNG. Luckily, BPCL has agreed to supply. There could be some valve seat wear because there is no lubrication through the liquid fuel. So we need to make valve seats stronger, which is already done in grease engine. Fast filling process, heating of cylinder, hence underfilling happens if it is heating. So we need to fill slowly and preferably early in the morning. Failure of burst disc of cylinder valve and fuel consumption also needs to be checked. So these are some of the advantages and issue, but we can sail through and use CNG in BAJA SA India 2022. Yes, you can do simulation. You can use GT power or fire and boost to do a simulation to find out how would this vehicle behave with 100% CNG or with CNG with 5%, 10%, 18% hydrogen. And then you can do an experimental test and then compare your data in terms of validation of the fuel test. So that's all from my side. Now, as far as the engine is concerned, the Briggs and Stratton, my colleague from Greaves, Dr. Kalimuddin, will be speaking more detail about use of this Greaves engine and its salient features. Thank you very much. Am I audible?
Yes, sir. Yes, sir. You're audible, sir.
Yeah. So I will unshare now, and you can introduce Dr. Kalimuddin, and we'll take all the questions together.
Sure, sir.
Yes,
Hello.
I'd now like to invite Dr. Kalimuddin Saeed, the General Manager at Greaves Technology Center. He has over 25 years of experience in research and development. He has a PhD in mechanical engineering from NIT Warangal. He has an MTech from REC Warangal, and he's a BE Mechanical from Government College of Engineering, Aurangabad. He has filed a whopping 18 technical papers in various in national and international journals, and he has an expertise on single and two-cylinder diesel, gasoline, alternate fuel, dual fuel engines, and dual fuel engine optimization for three-wheeler and small four-wheeler vehicle applications. Over to you, sir.
Yeah, I'm audible.
Yes, Kalim.
Yeah, just I'll share my screen so that
Yes.
you can see my screen.
Not yet. Yes, we can see now.
Fine. Good evening, all. And I thanks BAJA team and especially Dr. Vora and all other team members to invite us for this BAJA project, BAJA 24. And I'm glad to see that now alternate fuel is also explored for this BAJA project. It will be certainly a good learning for students. And from Greece point of view, we are, I think, delighted to help student and to explore this alternate fuel application on BAJA vehicle. And whatever the engines has been selected, I think it's the proper engine. I have gone through all these presentations by Mundra sir and all other colleagues. So looking to that vehicle point of view, I think this will be a new experiment for the student and new exploration for the learning for alternate fuel technology on a BAJA project. So I'm going to the slide second. Yeah, just for the overview, I think alternate fuel technology is already proven on automotive side. And most of you can see the vehicles, CNG vehicles and LPG vehicles are flying. Either it is a three-wheeler or four-wheeler passenger cars and other things. And if you see the scatter of this or the bifurcation of it, it is considered as a bi-fuel, then a dual fuel, and then dedication. That is only either you use as a CNG or as an LPG application point of view. And in bi-fuel also, you can use as a gasoline CNG or gasoline LPG. And it is further classified as injection closed loop, considering emission point of view, because open loop will not support us for stringent emission norms. Wherein in open loop also there is, you can see we are using a gas air mixture, but in closed loop we are using as an injection system. So we'll be focusing on this engine because this will be the engine which will be used by the students on their BAJA vehicle. And from the dedicated point of view, if this engine wants to be used on the CNG, then this engine has having a capability of increasing compression ratio to 12 to 12.5. We have tested this engine for a dedicated application for CNG, but unfortunately, customer doesn't want to be used because our this engine is being used for the low-cost transportation like three-wheeler applications, wherein the driver could not afford to go to station keeping the vehicle there itself. So they use gasoline as a bi-fuel mode or lympho mode and till go to the filling station for the CNG and then use as a CNG as a full application. Coming to the limitation of gas air application, it is having a poor cold startability, then low engine output, then air fuel ratio control not precise, not suitable for turbocharging, a deceleration fuel cutoff not possible, wide production tolerances, then limitation on meeting proposed BS6 norms. These are the major challenges wherein we cannot able to use gas as mixture for this application point of view on this engine. To the advantages, already Dr. Vora has explained us what are the advantages of CNG and concerns for the CNG. Startability and drivability in cold condition would be a challenge. Then engine output would be a challenge because sometime because of the compression ratio, engine doesn't perform equivalent to the gasoline and there is a drop of power, say 15 to 10 HP. But if you optimize properly, it will suffice the requirement equivalent to the gasoline also. Then air fuel ratio control is one of the benefit out of it. Then the better catalyst warm up is there because it is a lean burn, exhaust temperature is high. So catalyst warm up happens earlier. Then deceleration cutoff is very much possible because of injections, then suitable for supercharging. Anyway, this single cylinder engine, there is no turbocharging or supercharging as such for this application. Then narrow production tolerances we can achieve with the injection system. Good transient behavior we can achieve on the vehicle. Then high potential for meeting proposed BS4 to BS6 norms. Now this engine has been upgraded to BS6. What we are going to offer it. So nothing to worry for the emission point of view. The concern is poor startability, of course, in cold condition, engine misfire and backfire. Since this engine is having a closed loop injection system, so this phenomena may not occur, misfiring and backfiring. Then catalyst overheating also may not occur because this engine is already tuned for lambda 1 unity. Then high exhaust temperatures is the concern here. So being a water cooled engine, this can be controlled very well on this engine. Then vehicle stalling, poor drivability because of the, if suppose engine is in air cooled, then there is a heat losses more. So there will be problem of poor drivability and everything. But whatever the engine has been offered for this project is water cooled. So this concern is also eliminated there. Catalytic poisoning, it depends on again optimization. Then corrosion, more detrimental to the intake valves. This engine is protected with this also. So stellite coated is there. So this, whatever the concern mentioned for the CNG application may not be observed on the engine what is been offered for the BAJA project. Into the technical specification, already I think a small technical briefing Dr. Vora has already stated. It is a 396 cc engine and port injection is there, having 7.25 kilowatt or 10 HP engine at 36 to 3400 RPM. And maximum torque achievable is 24.5, but we are restricting it to 21 to 22 because of the limitation of the gearbox what is being used on the vehicle. And we are having a power takeoff of a spline type. So the gearbox what to be matched for this vehicle, I think it will be easily available in the market for this spline crankshaft because most of the single cylinder has crankshaft as a power takeoff. So any gearbox can be easily matchable for this engine. Also, I think your limitation is 60 kmph. So I think this engine, what has been selected is a very reasonable engine for packaging point of view and for the speed point of view. And coming to the size, it is very small height, almost 449 cross 358 for 485 is the maximum height, which is also very less. Weight is approximately 46 kg manifold to manifold. Some increment of weight will happen because of the exhaust system and silencers based on the vehicle application. Coming to the technical features of the engine, it is a gas injection system, that means CNG. Then for gasoline, it is the carburetor driven because it is in linfo mode. Then electronically control ignition and fuel, drive by wire, electronic governing system, deceleration, fuel cutoff, stoichiometric combustion. It is already optimized, so not much efforts is needed for optimization on the vehicle packaging or on the engine steady state. BS6 emission compliant with an OBD2 norms also. Then free acceleration, fast acceleration response, single cylinder water cooled engine, fueled CNG as well as gasoline as a lymphome, ECU control port CNG injection plus carburation for gasoline, closed loop breather system. So there will not be any say oil seepages from the breathers and other things. Usually small engine has this phenomena of leaking oil. So this oil leaking will not be there on this engine. Then flywheel having an integrated magneto. Suppose you need some current requirement for the vehicle lighting and other things that can also be taken from this engine. Then cast iron cylinder head and barrel. So in case this project is been taken for hydrogen assessment, so it can easily be taken because wear and tear and sustainability of the material for the hydrogen is very good for cast iron and other applications. This already I have spoken about the height, width and length. So I'll just skip this slide. To the peripheral parts of it, it consists of CNG injector, carburetor, then high tension coil, starter motor, means it is electrically started. Then flywheel with alternator, engine feet for mounting proper on the vehicle. Then engine mounts, then aluminum low pressure die casting crankcase. Then water pump is there. and spark plug is okay. From the PTO side, if suppose power takeoff side, you can see the exhaust system is there, then power takeoff, from where you have to fit the gearbox. There are 6 studs mounting is there. So casings are available in the market to suit this PTO cover, and even we will support you for that to get that casing to match the gearbox requirement for this engine. Then oil filter, oil pressure, then water outlet to be connected to the radiator, then engine hook that is for lifting, then oxygen sensor that is for lambda and other, then CNG filter. Everything is mounted on the engine, nothing to be taken on the vehicle side. So that is a relief for the students. So it will be complete pack of the engine fitted on the engine itself. You can see one of the view of the packaging of the 3-wheeler, wherein it is cross mounted. That means whatever the vehicle is being shown for the BAJA, this engine can be easily packaged behind the driver. And power takeoff can also be taken because it is a rear mounted, where propeller shaft and articulation has to be matched as per the requirement for the BAJA vehicle. Because the vehicle what is being used here is of a 10-inch tire, and I think what BAJA is using is somewhat bigger tire. So that articulation of the propeller shaft with respect to the gearbox is necessary to be studied and packaged as per design requirement. Radiator is very small radiator that can be packaged in front or back side of the engine also. And I think the heat capacity is almost 5,000 to 6,000 kilojoule. So it's not a problem. This engine radiator is easily packageable on the BAJA vehicle. Schematic layout, what to be mounted on the vehicle and what to be mounted on the engine. So engine is having all the systems as such. And from the vehicle point of view, you have to fix the CNG tank, then regulator, then ECU, then air filter. This is to be mounted on the vehicle. Battery has to be on the vehicle. Then filters, CNG filters and other things has to be mounted on the vehicle. So major challenge for the students will be for the CNG tank fitment.
Yes.
So appropriate tank selection for the vehicle size point of view is necessary. That has to be studied carefully. And for the other sides, for the packaging and accessories, Greece will support you for that.
Yes.
Yeah. And the block diagram for engine management system, the ECU controls sensors as well as actuators. So the coolant temperature sensor, lambda sensor, TMAP, that is temperature manifold pressure, then crankcase sensor. These are all fitted on the engine, so nothing to be worried. So whatever the engine control unit ECU will be there, that will be a separate part. So wiring harness has to match the couplers of these sensors. And then for the tank, cylinder tank, there will be ITVR, the integrated tank valve regulator, that has to be mounted on the vehicle. Then LP gas line, that is LP filter, has to be mounted on the vehicle. Then LP gas line, that is injector for the injector, that will be mounted on the engine, nothing to worry. So only this piping has to be done properly to take it from vehicle chassis and properly match to the CNG kit. Then carburetor will be, this will be the actuator where all signals will be given from ECU to the actuators like injector, then carburetor side, then spark plug, then high tension coil. So it is a closed loop system on the engine itself. Looking to the performance graph, this is almost a 10 HP engine, and you can see the torque value. Torque, it is on total flat torque, so more suitable for all-terrain vehicle application where drivability is must in different terrain testing of the vehicle. So coming to the onboard diagnostic, if suppose you want to verify and you want to loop diagnostics also on the vehicle, so that provision is also there in the control unit. So this can also be demonstrated and can be verified for this all-terrain vehicle, how it behaves with this diagnostic when it has been tested on this ATV vehicles. Coming to advantages, this I think Vora sir has already covered. It's the green fuel. There is low sulfur, the sulfur-free, lead-free, CNG reduce harmful emissions. Then it is having a very high auto ignition temperature, more than 540 degrees centigrade, and it is a very safe fuel. It is stored in a tank which is means tested for all safety point of view. So it is seamless cylinders. So nothing to worry for testing this on all-terrain vehicle. Coming to the dual facility, CNG vehicle can run both on CNG as well as gasoline or petrol. Then increased life of oil. It is actually low ash content oil is being used. So lubrication oil life is better in the CNG engines as compared to diesel and other gasoline engine application. And low cost of operations. These are the advantage for the CNGs. So I think this much only the presentation, sir, from my side.
I have a question for you, Dr. Kalimuddin. Excellent presentation. I think all the students here would understand everything about the engine. So is this same as Alpha engine of Mahindra? Mahindra Alpha CNG uses the same engine?
Yes, sir. Across the OEMs, overall India, except TVS and Bajaj Auto, they are not taking, but all other vehicles are using same
Okay,
engine.
can you tell some vehicle model so that the students can go and see that engine then?
This vehicle, sir, whatever the vehicles flying on the road with BS6, with our engine is with this engine only.
So Mahindra, Atul Auto, even Piaggio?
No, Piaggio is not using. Atul Auto vehicle is using, Taxi is using, and then JSA Auto is using. JSA, there are a lot many vehicles in Pune, I have seen.
Okay.
Yeah.
So students, if you want to see this engine, you can see in Mahindra Alpha or whatever sir said, those 3-4 vehicles, wherever they are in India and wherever you are located, you can have a view of that engine. And finally, this engine will be supplied from Greaves to all of you for hBAJA. Regarding mBAJA, we have not taken any decision.
Sir, one more thing I want to tell to students. They are welcome to visit Greaves anytime, just to intimate us. And we can show the vehicle also to them, how it has been packaged. And in case any support is needed or assistance is needed towards the gearbox side, that also can be taught to them.
Yeah, so Dr. Kalimuddin, we will be conducting some workshops, physical workshop. So we will do one workshop in Aurangabad in some college, and we will arrange the visit. And also you can show us one engine and explain to the students physically. So we'll do that.
We are open for it, sir. We are open for it.
Yes. Dr. Kalimuddin, I had one question. So the engine is generally in the rear, and the fuel tank and the CNG cylinder are above the engine?
Sir, for the three-wheeler application, what they are doing, they are just keeping beneath the driver seat.
Okay.
And for the front, there are two models of these vehicles. One is front mounting and another majority of them are rear mounting. For the front, what they are putting, this cylinder will go below the deck or rear side of the deck of the vehicle. Most of the are load carrying vehicles. So that cylinder goes below the deck.
Yeah, so for BAJA vehicle, the engine would be in the rear and the fuel, the petrol tank will be above the engine, right?
Yes.
So that 3.8 liter is the capacity of the petrol tank, right?
Yes, sir.
Yeah. And then where could be the CNG cylinder? Any suggestion?
Sir, looking to this vehicle, what is my suggestion that it should be beneath the driver?
Okay, but this is, the driver is sitting at the floor. So there is nothing below the driver. But anyway, we'll do a design review and then we will discuss jointly where can be the position of cylinder. That is something.
Yeah, because there are different size of cylinders, sir. So for the students, I think they can select the lowest size. I think there is a 4 kg cylinder is also there. 3 kg cylinder is also there. What Bajaj Auto is using. So that can be packaged beneath beneath the driver seat, and driver seat has to be slightly made up.
Okay, so now let us look at some of the questions.
I have some points.
Yes,
Mr.
yes.
Senator. I would like to know this vehicle engine, what you have made, is suitable for these three-wheelers, fine. And you are saying that you are able to meet the BS6 norms with this OBD2 requirements.
Yes, sir.
As I see from the application engineering point of view, suppose if we are required to remove complete after treatment of the exhaust gases totally, it frees up a lot of space. And I see that that is the best possible location to put the CNG cylinder in that location. Possibility A, we have to really explore and examine. To me, it looks all right. But if we do that, then after treatment is completely removed. I would like to know whether it goes back to Euro 4 or BS4 norm, or whether it is able to make BS5 norms or whatever it is. Because today there is no such regulation which is required to be fulfilled as far BAJA vehicle is concerned. This is point A. And point B is that what is the likely change in the engine performance in respect of power curve, torque curve, and the fuel consumption if the after treatment was completely done away with on your engine? Will it need also a ECU recalibration of any kind, or the same ECU can be used?
Sir, coming to the first question, if suppose we remove this exhaust exhaust after treatment and test this engine will come to Bharat stage 2 emission level. That is one. Stage 2 level, yeah. And coming to the calibration point of view, usually, sir, we don't have a lambda sensor, post lambda sensor. We are having a pre lambda sensor.
Okay.
So as such, I think it may not impact the performance of the engine.
Okay. So we have to accept then in that case a BS2 engine without the after treatment.
Yes,
then,
sir.
Then everything is feasible. We need to
Yeah.
explore. It was just a wild thought that if we want to create, because we cannot have the CNG cylinder definitely below the driver's seat.
There is no space.
There is no space, and the length of the cylinder will not be able to match that available width from the roll cage. Third is that in case the cylinder has to be changed, of course, cylinder you are putting externally, you are charging the gas. But suppose if the CNG cylinder was to remove, every time one will end up with removing the driver's seat and taking out the cylinder. If something can be, just like we have on the hBAJA battery can be slided out. Same way, if the CNG cylinder we are able to manipulate in terms of installation and removal, that will work better. That will work much better.
Sir, I stated you, this will be a good challenge for the students to package and redesign this total structure of the vehicle. Because this is the first time I think students will be trying alternate fuel application. And CNG cylinders are available, but my suggestion, students should focus to package this cylinder as lower side, because it will have its own weight. And this vehicle has been tested for all terrain application. So suppose the weight is slightly above, so there may be imbalance for the vehicle to test at the hilly and the bumpy roads.
Yeah,
Yes, yes. We have to think from vehicle dynamics point of view. I think we will discuss this separately with the organizing committee and then revert back. So, Hari, are there any questions related to engine, specifically related to engines?
Yes, sir. There's this question. Well,
Along with the Greaves engine to a normal hBAJA engine, which is currently, say, with a Briggs & Stratton engine.
Can you repeat the question?
How many more components have to be added along with the Greaves engine to a normal hBAJA vehicle, which is currently having a Briggs & Stratton engine?
Briggs & Stratton engine and the Greaves engine are totally different. No components can be combined together and done. So all hBAJA engine S1 today are using Briggs & Stratton engine. In case we are changing the engine, we will let you know. Right now for hBAJA, it is 100% Greaves engine. Briggs & Stratton engine is not to be used.
I think what the question is saying that, do they have to do any design work on the engine? No. It's only
no, it is a ready-made CNG engine. They have to just fit the engine. Yes, they can play with the exhaust system during the Go Green event. So that is the only scope. Otherwise, they will not make any change in the engine.
There's one more question about what is the transition cycle from CNG to HCNG to complete hydrogen?
What is the transition?
transition cycle from, say, currently it's purely CNG, then to hCNG, and then completely to
Yeah,
pure
so-
hydrogen?
Yeah, as I explained, for BAJA 2024, it is 100% CNG. For BAJA 2025, it is CNG with 18% hydrogen. And for BAJA 2026, as the country moves on and the hydrogen is available, we'll keep on increasing the percentage of hydrogen. And one day we will have 100% hydrogen. Now, when that will all depend on how the petroleum industry is producing hydrogen and is available for the automobile.
Sir, Kalim here again, just to inform to the students and to the team, this engine was also explored for hydrogen as a fuel by Professor L.M. Das of IIT Delhi.
Yes,
He has done some experiments on the same engine.
Yes.
So I think if the students are keen to get, you can get some data from L.M. Das also, Professor L.M. Das.
So Kalim, we
of
will
IIT
work
Delhi.
together. We will work together. We have 1 year to start working with hCNG and then finally hydrogen. But gradually our final aim is that we must use green hydrogen.
Can mBAJA teams participate in hBAJA?
Yes, mBAJA team can participate in hBAJA. The number of team members, the name of the team members have to be different because both the events are going to be concurrently held at Netrax at Pithampur near Indore. So if there are 25 members and they have 2 cars, one mBAJA and one, it will be difficult. But if there are 50 members from the same college, 25 for mBAJA and 25 for hBAJA, it is possible.
But I think initially there will be some limitations on the number of entries of for the.
Yes. So we will take that decision when the registration is complete. At that time, we will take the decision. So by month end, we must be able to take the decision. The last day for the registration is 20th May. And then the fees have to be paid. So till 20th May, the team must not pay the fees. They must pay the fees once we give the clearance between 20th May and 30th May. And there are some early bird payments facility also available where you can get a 5,000 rupees discount if you pay on time. All these details are mentioned in the registration docket, which is already uploaded on the BAJA website today. And the registration has started from today.
Okay, so one participant have raised a hand. Ganraj Singh, any question you have?
Vishwam, you said something?
Yes, sir. One of the participant have raised a hand. Ganraj Singh, if you have any questions, please ask.
Yes, sir.
The question,
Welcome
Vishwam?
to-
Hello.
Yes, sir. Am I
Yes,
audible?
Vishwam, what is the question?
Yes, sir. He's
Uh,
speaking.
Yes, sir. Respected
Jatayu.
sir, what would be the yes, sir? What would be the future for mBAJA, sir? Would it be discontinued?
No, mBAJA will not discontinue. All 4 events will coexist. mBAJA, eBAJA, hBAJA, and aBAJA. All 4 events will coexist.
Okay. Okay, sir. Thank you so much. Sir.
Like it is like India is the land of diversity. All alternate fuels are coexisting. Similarly, all these 4 events will coexist.
Okay, sir. Thank you, sir.
Thank you. I think they can raise hand and we can unmute them one by one in case they have any questions.
Yes, sir. So there is no more hand raised.
Yeah.
So what is the estimated price of the Greaves engine?
I can say only that much that it is less than 50,000 and it is much cheaper than Briggs and Stratton and Kohler engine. But the exact price is not yet decided. We are discussing with Greaves and we are yet to get the quotation. Shreya has raised the hand.
So, so this engine is compatible for both fuel as well as CNG, right? So for 2024, during the events, we'll be using CNG. Otherwise, during pit stops, etc., we can run on fuel.
Yes, we can run on gasoline and both fuel will be supplied by BPCL. You will not be using your fuel. That is what is our understanding as on today.
So, sir, when we're testing the car for during our college hours, so we should be using preferable is fuel, right? Because if we don't have
listen
CNG,
carefully. When you are going from one place to another and you are not validating the vehicle for any particular event like speed, like speed, acceleration, that time it is suggested you must use only petrol. But when you are doing test, when you are validating your vehicle, for maximum speed or acceleration or brake test, it is advisable to use CNG. And CNG is available in many parts of the city, many cities. Teams where CNG is not available could be a problem. They can use gasoline and then they can decide. For example, between CNG and gasoline, there may be a 10 to 20% drop in power, so that they can interpolate. So suppose they are testing with petrol, then the power will be more. If they're testing with CNG, the power would be lower. So that much extrapolation, interpolation they can do in case CNG is not available in their city.
All right. Thank you, sir.
But during the event, CNG will be provided. There is a question whether we have an option of choosing between hBAJA and hBAJA. Only those teams who have participated in hBAJA in 2022, 2023, and will be participating in 2024 are only allowed to participate in the autonomous BAJA. That means they must be using a ready-made vehicle and concentrate in the hardware and the software and its integration, and not in suspension, steering and brakes, or not in battery and the motor. And hence, only those teams who has a ready-made hBAJA vehicle can only participate in autonomous vehicle. But the team in 2024 can register for hBAJA and autonomous BAJA both. They can first participate in hBAJA event, which may be somewhere in March, January to March, and then they can convert that hBAJA vehicle into an autonomous vehicle and participate once again after 2 months or 3 months. So that is what is the plan. So there is a discount of 40% if you apply for hBAJA and hBAJA together in the registration fees. All these details are given in the registration docket, which is there on the website.
If there are no questions, shall I quit?
Yes, yes, sir. Yes, sir.
Thank you.
There is a question about how can we visit Greaves. So we will conduct a workshop in Aurangabad. That time we will arrange your visit to Greaves, and we will also show you a demo of the engine. And we will also tell you what are the precautions to be taken in the engine, safety precaution for CNG, and the service manual. So we will be also sharing the service manual of the engine with all of you.
Okay, sir. So maximum questions have been covered. So we will move forward. I will like to call Mr. Pranav Khatekar, co-head for the BAJA Alumni Committee 2024. I would like to invite Pranav to have a thank to the Dr. Kalimuddin. Pranav, over to you. Pranav, sorry to interrupt. If you are speaking, you are not audible.
Oh,
You can unmute, yeah.
Yeah, now you are audible, yes.
okay.
Yes.
I'm sorry. So thank you so much, Vishwam. Very good evening to all of you who are present for this 2-day introductory workshop of BAJA SAEINDIA 2024. I'm here today as a proud member of BAJA Alumni Committee to express my heartfelt thanks to all those who have made this event possible. I would like to start by thanking all the sponsor partners of the BAJA SAEINDIA and then the support institutions, namely ACMA, SIAM, ASDC, AICT, ARA, etc. On the behalf of the organization, I would like to extend my warm gratitude to the esteemed speakers, Dr. K.C. Vora sir, Mr. Sanjay Nibande sir, Dr. Sudhir Gupte sir, Mr. Vinay Mundara sir, Mr. Akhand Pratap Singh, Dr. Aryan Sharma, Mr. Arun Shankar, Mr. S. Ramanathan, Dr. Kalimuddin Said, Mr. Revant, and Ms. Monica. I would like to thank all the participants as well as the faculty advisor for attending this 2-day introductory workshop and make this event a grand success. And last but not the least, I would like to thank all the organizing committee as well as alumni committee members for the seamless conduction of this 2-day introductory workshop. Thank you everyone for joining and wish you all the best for the upcoming season of BAJA India.